This webcast looks at Worksheet 2B, questions 3 and 4. So question 3 gives us a position versus time graph that is showing the motion of two people on bicycles, cyclist A and cyclist B. And we've got several questions that we want to try to answer using this position versus time graph. So first of all, do the cyclists start at the same point? And how do we know? Well, if I want to know where they start, I want to look at time 0. And the place where these graphs are at time 0 is the y-intercept of the graphs. So the y-intercept of each graph identifies the initial position. I can see that cyclist A is beginning at position 0 meters, but cyclist B has a higher position at time 0. So you could think about this as cyclist B having a head start. Okay, at time 7, which one of these two people on bicycles is ahead? Well, so first I'm going to just identify where 7 seconds is on the graph. And as I look at this, if I want to know the position of each bicyclist, I need to take my finger and draw horizontally over to the y-axis to read off the position. And I can see that at time 7, cyclist A has a higher position than cyclist B. So A is ahead in this race at time 7. So which one of the cyclists is traveling faster at time 3 seconds? Well, if I just read coordinates off of the graph, I'm going to get position and time. So I have to look at something else to get an idea of how fast, and I think that's related to the slope. Actually, it is the magnitude of the slope that identifies the speed. So cyclist A, their position versus time graph has a steeper slope than the line that's showing the graph for cyclist B. So therefore A is moving faster at time 3 seconds because it has the steeper slope. Is there any point where their velocities are the same? In this particular race, no, because both cyclist A and cyclist B are moving at a constant speed. And I know that because both of these graphs are linear. The slope of a line is the same everywhere. So for all of the time that's shown to us, cyclist A has a steeper slope, and therefore cyclist A is moving faster. They are never moving at the same velocity. What about that intersection point where the graph of cyclist A crosses over the graph of cyclist B? What's happening there? Well, at that time 5 seconds, both of these cyclists are at the same position. So we're seeing a point where they're both at the same position at the same time. We could think of this as cyclist A is starting to pass cyclist B at that point. Let's try to draw a motion map that represents the motion of both of these bicyclists. So if I'm going to have a motion map, I need to label the axis, which is showing position. And so I'm going to put in a scale there so that I can tell what I've got. And I'm going to first show the motion map for cyclist A. I'll draw A's motion map above this scale. I'm going to draw B's motion map below the scale. Now for cyclist A, I know that at time 0, cyclist A is at position 0. So my first dot is going to occur at position 0. The position versus time graph here is descriptive. It's qualitative, but it does not give me enough information to actually calculate the amount of the slope so that I know the speed of either of the bicyclists. But I do know that A is moving faster than B because A's slope is steeper. So for the sake of doing the motion map, I'm going to just choose that cyclist A is moving at 2 meters per second, while cyclist B is moving at 1 meter per second. I'll still be able to get a motion map that represents this type of motion. Okay, so I'm going to put for cyclist A, my first dot goes at position 0. At the next dot for time 1 will go at position 2, and every second cyclist A's position should be increasing by 2 meters. And so I end up with a motion map for cyclist A that looks like this. The dots, which are showing position, are spaced 2 meters apart. The velocity vectors, those are the arrows, are pointing to the right because A is moving in the positive direction. And all of the arrows are the same length because A is moving at a constant speed. Okay, so now I'm ready to put in the motion map for cyclist B. One issue I run into is that I really don't know the starting position of cyclist B. I know it's bigger, it's at a higher position than where A started, but I don't know the specific value of it. The one place where I definitely know the position of cyclist B is at time 5 seconds, because at time 5, cyclist B is at the same position as cyclist A. So here I've shown 8 seconds worth of data, but I'm going to look at time 5 specifically because something special is happening there. Both cyclists are at the same position. So here at time 5, I'm going to put a dot for the position of cyclist B, and then that will represent time 5 seconds. I'm going to, on either side, put dots that represent the motion of cyclist B. And since I decided, in order to show B moving slower, I just arbitrarily chose a speed of 1 meter per second. The dots for cyclist B are 1 meter apart. The velocity vectors for cyclist B also point to the right because B is also going in the positive direction, and B's arrows are all the same length because B is moving at a constant speed. So I think we got a motion map that represents the same type of motion that we saw in the position versus time graph. Let's go on to number 4. Here they're showing the original graph, but on the right hand side they're giving us a new graph for these two bicyclists. And so first question is, how has the motion of cyclist A changed? And I can see that cyclist A has changed direction. I know that because the slope is now negative instead of being positive. But if I think about the amount of the slope, that they look about the same. So I think cyclist A has changed direction but is moving at the same speed. And of course, now that A is moving in the negative direction, their initial position is now at a much higher position. And what about cyclist B? I think the motion of cyclist B has not changed at all. It looks identical to what it was originally. So which of these two cyclists has the greater speed? Well, we need to look at this slope, and cyclist A, the magnitude of its slope is steeper than the magnitude of the slope for cyclist B. So even though A is going in the negative direction, maybe the value of this slope is negative, but the amount of it is still greater than the slope for cyclist B. So A is moving at a faster speed. And what about that intersection point where the graph of A and B cross? Well, again, that intersection means that both cyclists are at the same position at the same time. So they're passing each other. Which cyclist has traveled further during the first 5 seconds? Now this is an interesting question. So I probably want to look at the displacement of each cyclist during that first 5 seconds. And to find the displacement, I need to take the difference, the final position, that's the position at time 5, minus the initial position, which was the position at time 0. And you can see here that for cyclist A, that displacement, the difference between these 2 points, is bigger than the displacement for cyclist B. So A has traveled further in that 5 seconds. And that makes sense, right? Because we said before that A is moving at a faster speed, and therefore A does move further during those first 5 seconds. And if we wanted to draw a motion map for this new graph, it will be a little different than the one we drew before, because cyclist A is now moving in the negative direction. So notice that all of the velocity vectors now point to the left. They are the position dots are still 2 meters apart, because I'm still assuming cyclist A is moving at 2 meters per second, but the arrows are pointing to the left. And to put in the motion map for cyclist B, I'm again going to take advantage of the fact that I know that at time 5, these 2 cyclists are at the same position. And so at time 5 on my graph, I'm going to circle that so I can pay attention to it, and I want to put a position dot for cyclist B at that same position at time 5. Now cyclist B, the arrows are still going to the right because he is still going in the positive direction.